Hi guys, I am Yashodhan Agnihotri, a final year student at IIIT Pune, and I will be your host for today. Welcome to our channel, Learn Competitive Programming with CodeChef. On this channel, we post weekly problem explanations and concept videos. Also, if you are interested in competitive programming and want to master data structures and algorithms, this is the place for you. So, what are you waiting for? Click on that subscribe button and kickstart your journey towards competitive programming today. The problem in discussion today is from the recent April Long challenge, and the problem name is Chef and Dice. The difficulty level of this problem is cakewalk and the prerequisites are none. Let us try to understand the problem statement. So Chef has n six-sided standard dice. So we will see what a standard dice is. Each die has dimensions 1 into 1 into 1. Since Chef is bored during the quarantine, he decided to stack dice for fun. First, Chef forms 4 vertical stacks of dice, not necessarily with the same height. Empty stacks are allowed on his table, which together make up a pile of dice with base area up to 2 into 2. So, we will see this is the top view of the stacks. So, there are 4 stacks, and we will be piling up dice on top of each other in these stacks. Now, among all such structures, the total visible surface area of Chef's structure must be the smallest possible. So, we will see what significance this statement has. Then, Chef calculates the number of pips on the visible faces of all the dice in the structure. So, pips is basically the number on the dice. So, basically, if we have this, then these are 5 pips, right? So a face of die is visible if it does not touch the table or another die. Cool. Now he is wondering, among all possible arrangements of dice, what is the maximum possible total number of visible pips? Now since he is busy cooking, he is asking you to solve this. So what we have been asked is to output the sum of all the visible pips on the dice, on the on the structure. So let us say we have two dice. So we have one dice and this is the second dice. So the thing to be seen over here is just a minute. So this is the top view of the stack of dice. So if we have 2 dice, we have to stack them side by side. That is this way. We can't stack them up something like this. One is here and one is here. We cannot do this because this has more visible surface area, and hence this condition, this visible surface area condition, this will get violated. So we have to stack them side by side. Okay. So if we have 2 dice, then let us see what can be the maximum total visible pips. So for standard dice, we have 6 opposite to 1, 5 opposite to 2, and 4 opposite to 3. So in these two, if you see, there are a total of 4 visible faces, right? So what we will do is, the 2 hidden faces, we can arrange the dice such that the 2 hidden faces are 1 and 2 respectively, right? So basically the sum on all the faces, it will be 6 plus 5 plus 4 plus 3 into 2, because this will be per dice. So it will be 36. So the answer for n is equal to 2 will be 36. Now we also saw sample case. Now let us proceed to the solution approach. So before starting off with the solution approach, I wanted to just show you this dice. So here, as you see, 6 is opposite of 1, 4 is opposite of 3, and 5 is opposite of 2. And this will really be useful in our problem, as we will look to place the dice in such a way that the higher numbers, that is 6, 5, 4, these are on the outside for most of the time. So now let us get to the solution approach. Now starting with the solution approach, we will go case by case, as this is a casework problem. So for n is equal to 1, we will see what the answer will be. So there will just be one dice, and we will see the top view of the dice. So here we can place 6 as then 1 will be the only covered surface. So here it will be 5 2 and 4 3. So this is the best possible placement of the dice for 1, and hence if you check out the sum for the dice, it will be 20. So for n is equal to 1, the answer is 20. That is you have just one single dice. For n is equal to 2, how will you place the dice? So you will place the dice side by side in this manner. So here now what we can do is that we can place 6 at the top, 5 at the side, and 4 and 3 at the opposing, right? So this will give us the best sum. So what will be this sum? Let us calculate. 4 plus 6 plus 3 plus 5. This is equal to 18, and into 18 into 2, it is equal to 36. So for n is equal to 2, this is the best placement of the dice. Now let's move on to n is equal to 3. For n is equal to 3, we will have something like this. So this will be the placement. Now for n is equal to 3, this dice and this dice will be same as n is equal to 2, because it will again be 6 and 4 3 and 5, and again over here 6 5 4 and 3. But for this dice we will just have 6 5 and 4, right? And this is pretty obvious why. So if you calculate, the sum for this will be equal to 51. So for n is equal to 3, this is the best possible placement, which gives us the maximum sum of 51. Now for n is equal to 4, we directly stack the dice side by side in the 2 cross 2 surface area, and for this it's directly 6 5 4 6 5 4, and same for these two, 6 5 4 and 6 5 4. So 6 plus 5 plus 4, it is 15, and 15 into 4, it is equal to 60. So we got the answer for one level of dice. So if we just have one level of dice, then the answer for it will be 60. Now let us move forward and let us see what other cases are possible. So here I will introduce the concept of levels. So here first we have on top. So for the dice which are on top of the stack. So if you see the sum of the dice on top of the stack, if we have all 4 dice on top, then it is equal to 60, right? But if the dice are not on top and they are in stack sum below the top, so let us see what is the sum there. So here basically what we will take the 2 greatest numbers, because each dice has only 2 faces visible, right? So we will take the 2 greatest numbers, which are 5 and 6. So 5 and 6 and 5 and 6, and same way for the other dice. So basically, if a level is totally enclosed, right, then maximum sum will be equal to 44. So for an enclosed level, the sum will be 44. Now let us check out if there are not 4 blocks on the top, that is there are less than 3 blocks as shown in this figure. So here you can see there are just 3 blocks on the top of the stack. So this space is empty, right? So this 4 is visible. This is the number of pips on the lower stack of the structure, right? So if you remove one block, then the top 4 of the below dice, it is visible, because since this is 6 and this is 5, so these will still be visible, and also one more 4 will be visible. So if you see, if you remove one more block over here, then another 4 will be visible, and this will be true for every block, right? So if you remove 3 blocks, then 3 extra 4s will be visible. Now let us define a variable called dice on top. So the value of this variable will be n mod 4, because as we place 4 dice in each stack, we will calculate how many dice remain to be placed at the very top of the stack. So dice on top will be n mod 4. So the remaining dice, that is we can calculate the height. So height can be calculated by is equal to n by 4, and we will calculate. So the height will give us the number of complete stacks, right? So if n is equal to 11, then height will be equal to 2. So 2 will be the number of complete stacks, right? And the dice on top will be n mod 4, so it will be equal to 3. So there will be 3 dice on the top. Now seeing this structure, we can see that there are two enclosed levels over here. So enclosed levels have a total sum of 44, as we saw, right? So 44 for the enclosed levels, and for the top level we have a sum of 60. Now say we have 3 remaining dice. So let's place the 3 remaining dice on top of this. So we place one dice here, one dice here, and one dice over here. So forgive my drawing. So basically we saw that when n is equal to 3, then answer is 51. So for these 3 dice, the answer will be 51, right? But we also need to ensure that we subtract the faces that these dice have covered. So these 3 faces are now covered, right? And we have placed 4 on them, so that least number is subtracted. So what we do is that we subtract minus 4 into 3. So we subtract 12 from this. So basically the answer for this case, where we have 12 dice stacked on top of each other plus 3 dice on top. So 51 plus 60 plus 44 plus 44 minus 12. So this will be our answer. Let us start with the C++ implementation. So here I've taken input n, which is the number of dice. Here I've stored a vector naming base values. So here I've stored the first 4 cases that we had seen, n is equal to 1, 2, 3. So for n is equal to 1, I've stored at the first index 20, which was the answer for n is equal to 1. For n is equal to 2, the answer was 36. I've stored at the second index. And for n is equal to 3, the answer was 51. I've stored at the third index. Here I've stored 0 because if n is equal to 4, it is a complete stack, right? So here I've stored 0 because there are no dice on top. Now dice on top, here it is a variable and its value is n mod 4, as I had discussed in the solution. Now height, it is again n by 4, and this does not include the top level of dice. Now I've introduced another variable over here named enclosed. So what does enclosed mean? So enclosed is that level, so the enclosed levels, right, having sum 44. So those will be height minus 1, right? Because height contains the filled levels, and the last level, it should be given as 60. So here I've added 60. So the enclosed levels will be height minus 1 into 44, which we saw that 44 will be their sum because 6 and 5 will be the only pips visible. Now having calculated these 3 values, now I have a simple if else condition. If height is equal to 0, that is we just have free dice, that is you have either 1, 2 or 3 dice, then answer is equal to base values of n. So we get answer from this. Else, then what will be our answer? Then answer will be equal to enclosed. We will take the enclosed levels plus base values of dice on top. So this was calculated to show that how many dice are on top. So base values dice on top minus 4 into dice on top. We saw this, that the dice which will be on the top level, they will cover the faces on which 4 was written. So that many we have to subtract. So 4 into dice on top needs to be subtracted from our answer. So this was our formulated formula for the problem. And now we will just output our answer on a new line. So that was the solution, and I hope you understood it. Thank you.